Kinetic and Potential Energy of a Roller Coaster by Ian Nicolai. Motivation and Cultural Significance. I love roller coasters and go multiple times in the summer every year to ride the roller coasters at Cedar Point. The reason I chose this project is to understand how roller coasters work using information I learned in LP 273. This also connects to my community because every year we have a local fair where roller coasters come called Berkeley Days. It's like a holiday for my city where everyone goes and rides roller coasters. These are the energy pie charts. All circles are the same, showing no loss in energy. This is the system schema. Scenario overview. I created a miniature roller coaster using insulation tubing and placed a marble at the start of the roller coaster. This miniature roller coaster is designed to show the marble's change in potential energy to kinetic energy as it moves along the track. To measure potential energy, we will measure the height of the track at the start and end and weigh the marble used. To measure kinetic energy, this will be done by tracking how far the marble traveled in inches converted to meters, then divided by the time it took in seconds to get to the end of the roller coaster, and weigh the marble used. Since we cannot use the final velocity, we will use the average velocity, then compare that to the final velocity by assuming little energy was lost. This trial will be done 3 times and averaged. Materials used: insulation tube, painter's tape, wall, measuring tape, marble, Sharpie, box cutter. Experimental questions. How does the potential energy and kinetic energy change as the marble goes down the tube? Is energy lost as it moves on the roller coaster? If so, where is that energy transferred to? What does the height of the marble mean for the total energy of the marble? How does the average velocity compare to the final velocity? Experimental design of the roller coaster. Why research helps society? This project demonstrates roller coasters engineering keeps us safe by using physics. This project helps demonstrate how energy changes during a roller coaster and how engineers design safe rides. Millions of people ride roller coasters every year, so it is very important for them to be safe. Background information. Kinetic energy is the energy that an object has that is due to its motion. Potential energy is stored energy that could be used to move and is based on the object's height and mass. Law of conservation of energy states that energy cannot be created or destroyed, but can be transferred to other forms of energy. Predictions. As the marble moves down the roller coaster, the kinetic energy will increase and the potential energy will decrease. I believe the total energy will not equal the kinetic energy plus potential energy as the marble moves down the ramp. I believe that this energy is transferred to other forms of energy other than kinetic energy and potential energy. This is the data. This is the calculations for start and average velocity. Results. Calculations for end final velocity. Data analysis. From start to end, the average time in seconds it took the marble to reach the end was 1.6 seconds averaged from 3 trials. The marble traveled 1.53 meters, giving the final velocity of 0.9557 meters per second. The starting height of the marble was 1.64 meters, while the end height for the marble was 1.33 meters, showing a drop in height which will drop the potential energy. At the end of the trials, there was kinetic energy, which shows potential energy was converted to kinetic energy at the end. The start total energy at 0.08036 joules is higher than the total energy at the end, which is 0.06745 joules. The average final velocity is much larger than the average velocity, which shows the marble speeds up continuously. Scientific reasoning. The reason there was less energy at the end is because energy was converted to other forms of energy, not just kinetic energy, and was converted to other types of energy, such as thermal and sound energy. This experiment supports the law of conservation of energy because energy cannot be created or destroyed, but it can be transferred to other forms of energy. At the start, the marble only had potential energy, and at the end, energy was converted to other forms of energy, such as kinetic energy. The marble is always speeding up, which is why the final velocity is so much larger than the average velocity. Uncertainty and error. There's definitely a little bit of timing error because human reaction time could cause the average time to be slightly off. Height measurement error could have also affected this experiment because small inches error could change the meter conversion, change that can affect the potential energy. Friction in the track because it is not perfectly designed roller coaster. If some parts of the track were not as smooth as they should be, it could cause more energy loss than it should be. Mass of marble may have been off because I used a cooking scale to measure the mass of the marble, which can mess up the weight. Average velocity is not final velocity. Reflection. Potential energy decreases when the marble dropped from a height of 1.64 meters to 1.33 meters. The final velocity, when assuming minimal energy was lost, showed the marble was moving much faster than the average velocity suggests. The total energy being lower partially due to the average velocity and also partially due to the loss from friction and sound energy. Despite the measurement errors, the overall trend matched predictions with potential energy being converted to kinetic energy and some energy being converted to other forms of energy. This is the class problem. These are my references.